Hi friends, good morning to everyone. Welcome to my channel Belagali's class. Belagali's class. Yes, my friends, already we have started with vectors. Completed three classes. Yes, done in the previous class. Explained about the position factor of the point P. Point P. This is the point P. This is the point P in the space, my friends. In the space. Space means it has what? Three coordinates, x-axis, y-axis, z-axis. According as each point in the space has what? Three coordinates, x coordinate, y coordinate, z coordinate. Yes, my friends. If P is a point in the space, then vector OP is called as the position vector of the point P with respect to origin O. I, J, K are the unit vectors along OX, OY, OZ. Then position vector of the point P is expressed in terms of IJK. As x into I means what? X coordinate of the point P multiplied by unit vector in OX along the direction OX. Similarly, plus YZ plus ZK. Therefore, even we defined a position vector of a point P is represented by a point what? X, Y, Z. Therefore, a position vector of the point P can be expressed in terms of what? Unit vectors IJK. Xi plus Yz plus Zk, or in the form of the point also XYZ. My friends, before doing this, just I explained this for two axes, x-axis and y-axis. This is x-axis, this is origin, this is y-axis, this is the point P whose coordinates are x and y. Then this OP is the position vector. In that case, this OP is expressed as, here my friends comes I, this comes J, IJ. Therefore, a position vector of the point P is expressed as OP equal to XI plus YZ. Then, what is the magnitude of OP? Distance between O and P. What are the coordinates of O? 0, 0. Pxy, using distance formula, OP is square root of x square plus y square y. X minus 0 the whole square plus y minus 0 the whole square, that gives x square plus y square. The same we have extended to this, my friends, in the space. 3 dimension, 2 dimension. For the 3 dimension, point, origin, OP is the position vector of the point P, can be expressed in terms of IJK. Unit vectors in the direction of what? OX, OY, OZ expressed nothing but the point x, y, z. Then magnitude of OP is what? X square plus y square plus z square. This is one result. In this case, my friends, x, y, z, they are denoted as what? Scalar components of the vector OP. Scalar components. What are scalar components? The coefficients of IJK in the vector OP. And xi, yj, zk, they are called as vector components of the vector OP. Scalar components, vector components. I have done some examples, my friends, in the previous video. Just refer it. And this is magnitude. Even we have done to find the magnitude of the given vector. It is what? X square plus y square plus z square. There is nothing but coefficients of I, j, k. Sum and their squares, square and their sums. Yes, my friend. This is one result. This is what? AB is any vector. It is a vector joining the points A and P. From A to P is the direction. In this case, this can be expressed in terms of position vectors. Vector AB equal to position vector of the second point minus position vector of the first point. Similarly, even you can express what? you can express PQ vector PQ, tell my friend. This vector PQ can be expressed as what? Position vector of the second point OQ minus OP. OQ minus OP. Yes, my friend. Then this is the third result, my friends. Third result. This is the third result. Yes, my friend. Vector A. Vector A. Here, my friends, what happens? We can express this OP equal to vector R. OP equal to vector R. That is the distance between O and P is R. OP is this. Otherwise, you can say this is OP is nothing but vector R. Vector R. OP or vector R. Even this vector R is also called as position vector of the point P. OP is same as vector R. Vector R. Then position vector of the point is expressed in terms of ijk. Here we have taken vector A as what? A1i plus A2j plus A3k. It is in the form of a point. Vector B. B1i plus B2j plus B3k. It is in the form of point. Then sum of the vectors. Addition of the vectors A plus B. Just you have to add the scalar components A1 plus B1 into I, A2 plus B2 into J, A3 plus B3 into K. This is in the form of what? A1 plus B1 into I, A2 plus B2 into J, A3 plus B3 into K. It is in the form of a point. Just to add x coordinates. A1 plus B1, y coordinates, A2 plus B2, z coordinates, A3 plus B3. What is this, my friends? It is sum of the factors. If it is a difference A minus B, then you have to take what? A1 minus B1, difference of scalar components. A2 minus B2 into J, A3 minus B3 into K. Here, my friend, scalar components, difference. A1 minus A2, A2 minus B2, A3 minus B3. It is in the form of a point. Then what is this, my friend? It is a scalar component of the vector A. Lambda into vector A. Multiply. Lambda A1 into I. You have to multiply each scalar components by lambda. Lambda A1 into I plus lambda A2 into J plus lambda A3 into K. You have to multiply these coordinates by lambda, or lambda A1, lambda A2, comma lambda A3. This is one basic result, my friends. Based on this result, I have done some examples. See. These are 1 mark questions. If vector A equal to 2i plus j minus 3k, vector B equal to i plus 2j plus 4k, then find sum of the vectors A plus B. Second is what? Magnitude of 2a minus 3b. You have to multiply the vector A by 2, vector B by 3 and take the difference. You wanted its magnitude. Yes, my friends. A plus B. Add the corresponding coefficients A1, B1 into I. Here, my friend. 1. This is 2 plus 1 into I plus 1 plus 2 into J plus, here it is minus 3, my friends, coefficient of K, minus 3 plus 4 into K. Simplify this. 2 plus 1 is 3i plus 3j, minus 3 plus 4 means plus 1 into K. This is A plus B, my friends. This is the first result. Then you wanted, first you find 2a minus 3b. First you find the vector 2a minus 3b. Multiply this by 2, this by 3, then you take the difference. What I have done here is, I have multiplied 2 here, my friend. 2 with x coordinate, 2 into 2 is 4. Again, minus 3b, you multiply the x coordinate or coefficient of I by minus 3. Minus 3 into 1 is minus 3 into I plus 2 y coordinate, 2 into j means 2 plus 6 it is, plus 2, this is minus, my friend, minus 3 into plus 2 is minus 6 into j, third with k. 2 into minus 3 is minus 6. Minus 3 into plus 4 is minus 12 into k. Yes, I hope understood what I have done. Multiply by 2, multiply by 3. I have done at a stretch this. Multiply the I by 2. 2 into 2 is 4. I is outside. Minus 3 into plus 1 is minus 3. I is outside. Plus 2 into j. 2 into 1. Minus 3 into plus 2 is minus 6 into j plus. With k, that k you have to take common. Just you have to multiply with the components, scalar components. 2 into scalar component of k is minus 3, minus 6. Minus 3 into scalar component of what? K, plus 4. Minus 3 into plus 4 is minus 12. Simplify. 4 minus 3, 1. Plus 2 minus 6, minus 4. Minus 6 minus 12 is minus 18. It is 2a minus 3b. We wanted its magnitude. Square root of 1 square minus 4 the whole square plus minus 18 the whole square. 1 square is 1, minus 4 whole square is 16 plus 324. If you add them, 4 into 6, 10. 10 plus 1 is 11, 1. 3 plus 1 is 4, this 3. This is 341, my friends. This is first example of some scalar multiplication, everything, my friends. This is first example. This is second example. Find the sum of the factors. Sum of the factors. I plus 2j plus k minus 2i plus 4j minus 5k. I minus 6j minus 7k. Also find its magnitude. Denote them. Take the first factor by a, second factor by b, third factor by c. You wanted, my friends, the sum. Then a plus b plus c. Add what, my friends? Coefficients of I. 1. Here itself. 1. Minus 2 is what? Minus 1 plus 1. Otherwise, I plus I is 2i minus 2i is 0 into I plus 2j plus 4j. It is plus 6j minus 6j, 0 into j plus k minus 12k, minus 5 minus 7 is minus 12k plus k is minus 11k. If you simplify, you get minus 11k. You wanted its magnitude also. Magnitude of this square root minus 11 the whole square. 121. Square root of 121 is 11, my friends. I have taken these two examples with what? Particularly on a plus b, a minus b, and lambda a. These two examples, my friends. Yes. Then these becomes the basic results, my friends. Next, just I want to remind this definition. Already I have given this definition. A unit factor along or parallel to the factor a is denoted by a cap and is defined as a cap equal to factor a divided by its magnitude. My friends, this is the factor a. This is the factor a. What is this, my friend? This is a cap. What is a cap? Its magnitude is 1. What is its direction? It is along. Even you can take this a cap down. Down means it is parallel to this a cap is, my friends, it is parallel to the factor a. Along means same. Along the factor a. Magnitude, because it is a cap, means unit factor. Magnitude is 1. Magnitude is 1 and direction is in the direction of the factor a. Either you can take along, otherwise even you can take parallel. Like this, my friends. This is the factor a. This is the factor a. Then this is a cap, my friend. This is A cap, this direction. A cap means its magnitude is 1, it is along the vector A. Parallel means even the same thing you can take what? Parallel means the direction is same. What about its magnitude? Its magnitude is 1. Its magnitude of A cap is 1 unit. Why? It is unit vector. And what is the direction? It is in the direction of the vector A. Then this such a vector A cap is given as the same vector divided by its magnitude. This is a definition, my friends. Definition. Then I have done two examples based on this. Find the unit vector in the direction of the vector A. That unit vector needs what? Vector A upon its magnitude. You have to find the magnitude of A. Magnitude of A. Just I have explained, my friend. Coefficients of ijk, 1 square plus 2 square plus 3 square. 1 square, 1, 2 square, 4, 3 square, 9. 10 plus 4, root 14. Then what is A cap? A cap is factor A upon its magnitude. What is factor A? I plus 2j plus 3k. I plus 2j plus 3k upon root 14. Root 14 can be written as coefficient 1 by root 14 into I plus 2 by root 14 into j plus 3 by root 14 into k. It is also what, my friend? This A cap is expressed in terms of this. Now if you take its magnitude, what is the magnitude of this? 1 by 14 plus 4 by 14 plus 9 by 14. 1 plus 4, 5 plus 9, 14 divided by 14 is 1, my friends. Yes, my friend, this is A cap in this. One more example. One more example is what? If A equal to this and B equal to this, then you find the unit vector in the direction of A plus B. Unit vector in the direction of A plus B. Yes, my friend. Just go to find A plus B. A plus B, add them, plus I, add them, 0j, add them, plus k. Then wanted its magnitude, then what is this? Its cap is A cap, A plus B divided by its magnitude. We can find, otherwise I do it. Just copy this, my friends. All this you copy. Copy, 2 minutes time. 2 minutes time. Yes, friends, last 1 minute, quick. Last 1 minute, quick. Yes, friends. Next example. Otherwise, I can explain this once again. Example 2. Example 2. My friends, this result I have written here. If vector A equal to this, vector B equal to this is the sum. Addition of what? Scalar components of vector. In the form of point. What is that point? A1 plus B1 comma A2 plus B2 comma A3 plus B3 comma. Yes, my friends. That second example I do. Second example. That is A plus. This is example 2, my friends. Example 2. A plus B factor A plus B equal to, add them, A plus B plus 2I minus I is plus I plus minus J plus J, 0 J plus or minus 0 is uniform, 0 minus plus 2K minus K, it is plus K. Then you wanted its magnitude. You denote this vector by vector C. Then A plus B, its magnitude or magnitude of C is magnitude of A plus B. Yes, my friend. It is the square root of coefficient 1 square plus 0 square plus 1 square, my friend, it is root 2. Then C cap, what is C cap? A plus B the cap, C cap is factor C upon magnitude of C. What is it? It is I plus K, 0 it is. Denominator is what? Magnitude, root 2. So can be written as 1 by root 2 into I plus 1 by root 2 into K. Otherwise, you have to write in between 0 by root 2 into J. Otherwise, it is a 0, doesn't have any value. Okay, you can complete this. This is that second example, my friends. That second example. Now, the next example is yes, friends. Next example is find the unit factor. Example 3. Find the unit factor. In the direction of the factor PQ, where P is a point whose coordinates are 1, 2, 3, 1, 2, 3, and Q is a point with coordinates 4, 5, 6. Then you can write, if O is the origin of reference, OP, position vector of the point P, position vector of the point Q. Yes, my friends. If O is origin of reference, origin of reference. Then position vector of the point P, that is OP. What is it? 1 into I plus 2 into J plus 3 into K. Factor OQ. What is OQ? Yes, 4 into I plus 5 into J plus 6 into K, my friends. 6 multiplied by K. Then you wanted what is factor PQ. Then convert this factor in terms of position vector. Position vector of the second point minus position vector of the first point. Second point, first point. Tell my friend. 4i minus I. 5i, 5j minus 2j. Plus 6 minus 3, 3k, 3k. Or the same thing you can write it as what? Taking 3 common, I plus j plus k. I plus j plus k. Then you find the magnitude of this. Magnitude of this. Yes, friends. Magnitude of PQ. Magnitude of PQ. Yes. It is square root of 3 square 9 into coefficient 1 square plus 1 square plus 1 square. What is it? Square root of 9 is 3 into square root of 1 plus 1 is root 3. Root 3. This is magnitude. Then you wanted PQ cap is what? Factor PQ upon magnitude of PQ. Magnitude of PQ. Put the values. What is PQ? It is 3 into I plus j plus k. Denominator is 3 root 3, my friends. Get cancels. What is it? It is 1 upon root 3 into I plus 1 upon root 3 into j plus 1 upon root 3 into k. What is this, my friend? This is unit factor in the direction of factor PQ. Unit factor in the direction of factor PQ. Yes, my friends. It comes under 2 mark question. 2 mark question. Yes, my friend. Otherwise, 3 mark. OP, OQ, PQ. Yes. This is 1 mark. Magnitude and this formula. They may give under even 3 mark question also. 2 mark, otherwise 3 mark questions, my friends. My friends. Yes. Next is yes. Another type, slight change, my friends. Slight change. Yes, friends. This is PQ. Next example is yes, friends. Next is find the factor. This is example 4. Find the factor in the direction of the factor of the vector A equal to, this is 5i minus j plus 2k, which has a magnitude of 8 units of 8 units. Tell my friends, you wanted first is what? In the direction of the vector. Yes. What is this, my friend? This is a unit vector PQ cap. What is its magnitude, my friend? Magnitude of this is 1. What you wanted? Magnitude of 8 units here, my friend. To get the 8 units, you have to multiply this 1 by 8. Then, what is the numerator? You have to multiply factor PQ by 8. Then you find its magnitude. Here also, my friends, first you have to find A cap. Find first A cap. Then required vector is 8 times A cap. I tell my friends, what is the magnitude of A cap? 1. You wanted magnitude of 8 units. Find the factor of magnitude 8. This is with 1. If you multiply by 8, that will be your factor with 8 units, my friend. 8 units. Therefore, to find such a factors, first you have to find A cap, then multiply by 8, 5, whatever the magnitude you wanted, you have to multiply. Yes. Now to find A cap, first you have to find the magnitude of A. This is square root 5 square plus minus 1 whole square plus 2 square is 4. Which is square root of 30. Then A cap. A cap is factor A upon its magnitude. What is A cap? Is 5i minus j plus 2k. Denominator is A cap. A cap is root 30. Then you wanted what? The required factor is 8 times factor. Required factor is 8 times A cap. What is it? It is 8 times, what is A cap? 5i minus j plus 2k upon root 30. There is no cancellation here. Then you have to multiply by 8. 8 into 5 is 40i minus 8j plus 16k. Denominator is root 30. Otherwise, if you wanted the scalar components, 40 upon root 30 into I plus minus 8 upon root 30 into j plus 16 upon root 30 into j. What is this, my friend? Required vector whose magnitude is 8 units. One more, my friends, the parallel example. Yes. This is example number 5. Find the factor of magnitude 5 units 5 units in the direction of factor A equal to it is I minus 2j, my friends. Only this. Yes, I give 2 minutes to do it. I give 2 minutes to do it. You try. 2 minutes, my friends. 2 minutes. Yes, friends. I hope you have done it. Otherwise, you do it yourself, this example. Next, my friends. Next. You can say either definition or a result, anything. Anything. Yes, friends. You know what I mean by A cap? What is A cap, my friend? It is 1 minute. If factor A equal to A1i plus A2j plus A3k, then magnitude of factor A is square root scalar component, square and add. Yes, my friends, what is this? Magnitude of A. Then what is A cap? A cap is factor A upon its magnitude. What is factor A? A1i plus A2j plus A3k. What is this? Factor A upon its magnitude. I write in this form only. You know what is magnitude of A is? It is nothing but root A1 square plus A2 square plus A3 square. Then you write this as what? In the form of components into I plus A2 upon magnitude of A into J plus A3 upon magnitude of A into K. What is this, my friends? Remember, it is A cap. What about these three, my friends? These three are scalar components. Scalar components of A cap. Then there is a definition, or we can say there is a result. Scalar components of A cap are defined or are given as they are nothing but the direction cosines of the vector. Yes, my friends. Now, scalar components. Scalar components of A cap are called as direction cosines. Direction cosines. We write this in the short form, direction cosines of the factor A. Therefore, my friends, direction cosines of factor A are scalar components. Scalar components of A cap. What these? These are nothing but A1 upon magnitude of A, A2 upon magnitude of A, A3 upon magnitude of A. These are nothing but direction cosines of factor A, which are nothing but scalar components of A cap. Scalar components of A cap are defined or called as the direction cosines of the factor A. Yes, my friends, they may ask examples on this. Find the direction cosines of the given vector. What you have to do? You have to find A cap. Right in the form of what? Scalar components. Then what are the direction cosines? Coefficients of I, J, K. They are nothing but direction cosines of the given vector. This is, my friends, the theory part of it. Then I do one example or two examples. These are important examples, my friends, especially under 1 mark question. 1 mark questions. Even sometimes your luck is good. Your luck is good. Even you may get in CET also. CET also. Yes, my friends. First example of this. Example 1. Find the direction cosines of. I write it in brief. Direction cosines of the factor A equal to I plus 2j minus 3k. To find A cap, we wanted what its magnitude. Magnitude of A 1 square plus 4 square plus minus 3 the whole square, which is root 14. Therefore, A cap. What is A cap? Factor A upon its magnitude. What is it? What is factor A? I plus 2j minus 3k. Denominator is root 14 magnitude. Write it in the form of scalar components. 1 upon root 14 into I plus 2 upon root 14 into j. When there is a minus, you write that minus separate. Minus 3 upon root 14 into k. Yes, my friend. What are the direction cosines? Direction cosines of the vector A, nothing but scalar components of unit vector, that is A cap. What they are? Scalar components. 1 by root 14, 2 by root 14, and minus 3 by root 14. Yes, my friends. This is the method of finding the direction cosines when the factor A is given. Yes, my friends, these are good examples under 1 mark. Under 1 mark questions. I hope the method is clear. Simple. If you wanted, I do one more example. Yes. One more example. Yes, friends. Find the direction cosines. This is second example. Find direction cosines of the factor A equal to 5i minus j plus 2k. Yes, again you have to find A cap. To find A cap, you need what? Magnitude of A square root. Yes, squares of the components. 5 square plus minus 1 whole square plus 2 square 4. This is 26 plus 4 is 30. Then you have to find A cap. A cap. It is vector A upon its magnitude. A, what is it? 5i minus j plus 2k. Denominator is what? Modulus. Means magnitude of A is root 30. Write it in the form of scalar components. 5 upon root 30 into I plus, I told separate plus minus. Minus 1 into root 30 j plus 2 upon root 30 into k. What are the scalar components of A cap? Coefficients of ijk. Therefore, direction cosines of vector A are scalar components of A cap. What they are, my friends? 5 upon root 30, comma, minus 1 upon root 30, comma, 2 upon root 30, my friends. Root 30. Yes. This is the method of finding the direction cosines of the given vector. Such examples are important, my friends, on the 1 mark questions. They are star examples. Yes, my friends. You copy it. You copy it. Next result, my friends. Definition I give. Copy it. Yes. Definition, my friends. Definition. My friends, let P be a point in the space P, or even you can take the coordinates. P be a point in the space then OP is the position vector. OP is the position vector of the point P. Yes, my friends, if you wanted a figure, space means 3 coordinates. Yes, this is origin of reference. X-axis, this is y-axis, this is z-axis, this is your point P, then this is your vector OP, Yes, my friends, if alpha is, this is alpha is the angle made by OP with OX. My friends, this is beta. Which one? This one. This is beta. What is this? This is the angle. This is the angle made by OP with OY. Then one more is there. That one more is, my friends, this is gamma. This is gamma, my friends. This is gamma. So if alpha, beta, gamma are the angles made by the vector OP with OX, OY, OZ, then cos of the angle alpha, cos of the angle beta, cos of the angle gamma, namely cos alpha, cos beta, cos gamma, are known as direction cosines of the vector OP. Yes, my friends. The same thing I write now. Yes. Let alpha, beta and gamma are the angles made by the vector OP. Let alpha, beta, gamma are the angles made by the vector OP with OX, OY and OZ. Then their cos, then cos alpha, cos beta and cos gamma are called as direction cosines. Direction cosines, direction cosines of the vector OP. Direction cosines of the vector OP, my friends. Yes. Let P be a point in the space, then OP is known as position vector of the point P. Let alpha, beta, gamma are the angles. Let alpha, beta, gamma are the angles made by OP, vector OP, with OX, OY, OZ. Then cos of the angle alpha, cos beta, cos gamma are called as direction cosines of the vector OP, position vector of the point P, vector OP, and are denoted by L, small m, small m. These are the standard symbols, my friends, notations. L, comma, m, comma, n always denotes the direction cosines of the vector. Therefore, by this definition, my friends, by definition, we have, tell friend, L. What is L, my friend? L corresponding cos alpha. M, second cos beta. N, third cos gamma. Yes, my friends. This is the definition. Definition of what? Direction cosines. What is it? Space. OX, OY, OZ. All the three coordinates. 3D, my friends. P be a point in the space, then OP is the position vector of the point P. Alpha, beta, gamma are the angles made by these three axes, OX, OY, OZ. Then cos of those angles, cos alpha, cos beta, cos gamma, are defined or defined as direction cosines of the vector OP, and they are denoted by the letters small l, m, n. Therefore, by definition, my friend, L is cos, m is cos beta, n is cos gamma. I have written the same thing here. Yes, my friends. Yes. Now you copy it. Then you have a theorem. That theorem is a link between these. With, instead of OP, if you take the point P as what? X, Y, Z. Then what is OP? Xi plus Yz plus Zk. Otherwise, if you take what? A1, A2, A3, then what is OP? A1i plus A2j plus A3k. Then you have to find the link between these with that. There is one very important theorem is there. That theorem I do it in the next video or next class, my friends. Till then, this vector algebra is a very simple part of mathematics to second year. Very simple part. Useful, my friends. If you join higher classes, its use is there. Even To the point of board exam, you have 1 mark 1 question, 2 mark 2 questions, 3 mark 2 questions, totally 6 plus 4 plus 1, 11 marks. If you go for any competitive like CET exam, minimum you have 3 to 4 examples of factors. So, as an exam sake, this exam or that exam, it is an important chapter. What is its advantage? It is a simple, easy chapter, very, very useful in future, my friends. Saying this, today I will conclude. Yes, enough today. Yes, my friends. Till to the next video class. Bye, goodbye, namaste, namaskara, namaskar. Yes, my friends. Good day. Good.